All right, so number 13 from the multiple choice says, which of the following expansions is impossible? The way they word that isn't the best, but let's see, I need the toolbar here thing so I can get the pen. It's not showing up. All right, for our second attempt here, now that I can write on the screen. Number 13 says, which of the following is impossible? And which of the following expansions is impossible? And so the basic idea behind this one is, in order to expand out one of these things as a series, you need to be able to take derivatives of that function at whatever value you're going around for all values of, for all orders of the derivative. So if you're looking at, let's say, the first one is the one that's impossible, but if we look at A says we've got root x minus 1 with powers of x. And so powers of x mean that we are doing this centered around x equals 0. And so you need to be able to evaluate this function as well as all of its derivatives at x equals 0. Well, we can't evaluate this function at 0. And we can't evaluate the first derivative of this function at 0 or any subsequent derivative of this function at 0. If you look at choice B, just to kind of look through them here, that one's square root of x plus 1. And if you're going to do that one in powers of x, then it means you're going around x equals 0 again, but you can plug in 0 to this, and you can take the derivative of this and plug in 0 to x, and so on through all of them. For C, it's talking about ln x, powers of x minus 1, which means that we're going around x equals 1. And so you can take the natural log of 1, and then the derivative of natural log is 1 over x, which you can do at 1, and all the subsequent derivatives can be evaluated at 1. And so on. You can do the same with all the rest of this, just to sort of see that each of the derivatives could be evaluated at that value that you're going around, whereas A cannot. Does that make sense?
Yes.
Cool. All right, let's see. Somebody else asked now for 33. So let's see here. 33. We got the radius of convergence. And we got n equals 1 to infinity of x to the n to the n over 2 to the n times n factorial. And so we'll start off by taking the absolute value and the ratio test. So we'll do the limit as n approaches infinity of the absolute value of x to the n plus 1, n plus 1 to the n plus 1, over 2 to the n plus 1, and n plus 1 factorial, times 2 to the n factorial, x to the n to the n. Then we'll simplify as much of this as we can. So to start with, we will rewrite this by, let's see here. If I have n plus 1 factorial, that's the same as n plus 1 times n factorial. So I can just leave an n plus 1 in my denominator for that and cancel out the n factorials. X to the n plus 1 over x to the n should just be an x in the numerator. And then this should have a 2 in the denominator from the 2 to the n plus 1 and the 2 to the n. And then we still have this n plus 1 to the n plus 1. And we still have this n to the n. Everybody good with that so far? I guess I should put my fraction bar. Good. Okay. And then this is n plus 1 to the first. And this is n plus 1 to the n plus 1. And so I could subtract the exponents there, n plus 1 minus 1, to get rid of this one, and just make this n plus 1 to the n. So I have x times n plus 1 to the n over n to the n. And from there, n plus 1 to the n over n to the n could be rewritten as n plus 1 over n to the n. And that is a limit we've seen before if we sort of rewrite it a little bit. I mean, without the x over 2 part. But so x over 2, and then n plus 1 over n, if I divide those both by n, becomes 1 plus 1 over n to the n. And that should be familiar to you. What is 1 plus 1 over n to the n is not x goes towards infinity, but as n goes towards infinity. No, that's not 1. That's something you've seen. In fact, I know I've shown you all this. Well, maybe not. At least last year we talked about it. 1 plus 1 over x to the x. What is the horizontal asymptote? What are we approaching as x goes towards infinity? We are approaching e. Exactly, Alice, right? We're approaching e. So the part of that that is 1 plus 1 over x to the x, or sorry, 1 plus 1 over n to the n, is approaching e. And so this just becomes x over 2 times e. And so we want to make that less than 1. So we'll just multiply by the 2 and divide by the e, and we get absolute value of x is less than 2 over e. And so that would tell us that the radius of convergence is 2 over e. Sorry. Yeah. 2 over e, yeah. Half a second, I thought I multiplied those backwards and I should have had e over 2, but I don't know. Must be losing my mind. Good or no? No problem. All right, what else from all those multiple choice?
Okay,
18?
19.
19. All right, 19 says f is the Taylor polynomial of order 7 for inverse tangent of x so that x equals 0. Okay, and then it follows that if x is between 0.5 and negative 0.5, is the function greater than, or is f of x, is our polynomial greater than, or is it less than the actual value of inverse tangent of x? Okay, so let's first write out what is the 7th order Taylor polynomial. for inverse tangent. Or we should know what's the series for inverse tangent. We can start with that. Should be the sum from n equals 0 to infinity, what? Alternating, right? -1 to the n. And then it's x to the 2n plus 1 over 2n plus 1. If I remember my series correctly, which I hope I do. That look right to everybody? So that should give us our 7th degree Taylor polynomial, which is f of x, which should be just when n is 0, just an x. And then when n is 1, we should get a minus x cubed over 3, and we should get a plus x to the 5th over 5, and a minus x to the 7th over 7. Everybody agree with that? Okay, so then what's our next omitted term? Because that's our error, right? That's what we're interested in. Our error is going to be less than this x to the 9th over 9 term. And what can we say about x to the 9th over 9, right? Like this error represents the difference between f and inverse tangent x, right? That's what that error represents. This is the greatest amount of the error. And this is a plus term in here. And if x is positive, then this term is a positive value, right? So we would say that if x is greater than 0, then that should tell us that f of x needs to be less than the value of inverse tangent of x, right? Because to get the actual value, we need to add more onto it. But if x is less than 0, this x to the 9th over 9 term is a negative value, and that should tell us that we've gone over because we need to subtract to get back to the actual value. So f of x would then be greater than the inverse tangent of x. Does that make sense? Yeah, so we're approximating inverse tangent x using this 7th degree Taylor polynomial. We know that the amount that we're off by is this, right? We're off by x to the 9th over 9, or technically we're off by less than x to the 9th over 9, but we're off by that or a little bit less than that. And so this approximation is less than, our function is less than the actual value, which is what we'd get if we added this term and the infinite number of other terms that we have to it, as long as this term is positive, because we always alternate, remember, we always oscillate with an alternating series back and forth beyond the value that you're actually approaching. So if I put, after one term, after x, I'm above the actual value of inverse tangent x. After the minus term, I'm below it. Right? After I put in a positive term, I'm above it again. After I put in a negative term, I'm below it again. So after I put in a positive term, which this is a positive term if x is positive, then I am, then my function would be back below it. Right? So after this term, after the x to the 7th over 7 term, if x is a positive value, I've gone to the left of the actual value of it. I've gone smaller than the actual value of it, because the next term, which will be a positive term, will have to bring me back to the right or to a larger value than the actual value. That makes sense to everybody? And then vice versa, if x is negative, it's the opposite. Okay, All right, let's see here. Somebody asked for something. Nick asked you asked me for 43, right? And then I got 17 after that. Okay, 43. All right, so 43 says that if we are using x minus x cubed over 3 factorial to approximate the sign of x, then we want to know how much we are off by. Well, the formula for sine of x, we know that that oscillates, right? And so if we're using just these two terms, we'd have to have an error of whatever the next term is by the alternating series. Error bound, right? The error is the next term. And so our next term would be x to the 5th over 5 factorial. And so at x equals 1, that's just 1 over 5 factorial, which is 1 over 120. And 1 over 120 is 0.0083 repeating. Okay, so we know that our error is less than 0.0083 repeating. And so it looks like the only one that is greater than that is 0.009, right? And so we know that 0.009 has to be more than what our error is. That makes sense? It's evaluated at x equals 1. Well, okay, so I chose x equals 1 because it says the absolute value of x is less than 1. And so that's telling us that the largest possible value that this could be is at 1. And so anything that we plug in that's less than 1, or it has an absolute value that's less than 1, is going to give us something that's even smaller than this is. I'm sorry, not smaller. It's going to give us something that's larger than what this is. Now, it's going to give us something smaller than what this is. I can do arithmetic. And so we choose the largest possible value for our error. And then we can say that our largest possible value for the error is clearly more than what the actual error would be for any value between -1 and 1 non-inclusive. Did that answer your question about why at -1, or sorry, why at x equals 1? Yeah. Okay. Any other questions on that one? All right. Yep, no problem. All right, so number 17. Let's see here. So 17 says we are going to use the series to approximate the integral from 0 to 0.3 of x squared e to the -x squared dx. And so then we want to know, correct to 3 decimals, what does that definite integral equal? And so we should know what the series for e to the -x squared looks like. Right? What does the series for e to the -x squared look like? Well, we could start with what is e to the We can start with just what does e to the x look like if we wanted to. You guys don't just have the e to the negative x squared one sort of in your head. What is the e to the negative? You guys know what e to the negative x squared is, right? You know what e to the x is, right? So you just replace all of the x's with negative x squares. So that should become, we'll still have an x squared there. And then we're going to have a 1, should become a minus x squared, should become a plus x to the 4th over 2 factorial, should be a minus x to the 6th. Over 3 factorial, and so on. Good or no? If that's the series for e to the negative x squared. Everybody good with that series or no? Okay, just making sure. All right, so then we can distribute the x squared through everything. So now we've got 0 to 0.3 of x squared minus x to the 4th plus x to the 6th over 2 factorial minus x to the 8th over 3 factorial and so on. And then we can actually integrate it to get x cubed over 3 minus x to the 5th over 5 plus x to the 7th over 7 times 2 factorial minus x to the 9th over 9 times 3 factorial and so on. And if we're going to evaluate this from 0 to 0.3 and we want it to be accurate, how many decimals do they say they want it to be accurate to? 3? We'll just plug it in until we know we're getting way more than 3 decimal points of accuracy. So 0.3 to the 3rd power should be what? Should be 0.027 and then over 3. And then this is going to be what? 0.00023 over 5. And then clearly all these other ones are going to be like way more than 3 decimals. I mean, this one is already more than 3 decimals, right? And so minus 0, if I plug in 0 for all of it. And so our answer should just be, well, that one's 0.09, sorry, 0.009. And this is already more than 3 decimals. And this term here, if I add an extra term to it, it's not going to change the rounding on that. So. And I guess that was choice A. Get it or no? Yeah, no problem.
18, please.
18, sure. And we'll do 44 after this one. So let's see, 18 gives us a series for inverse tangent at 1 to approximate pi over 4. We want an error less than 0.001. So that means we want, so we're going to have an error of 0.001. We want error to be less than that, which means that we need to truncate this at a term so that the next term to be less than greater than. I can write things really well. Our next term is less than 1 over 1,000. Right? Because that's what that is. That's 1/1000. And so if we think about that series that they give us a series for inverse tangent, right? Say it's 1 minus 1/3 plus so on. Right? Here's our first term, here's our second term, our third term, our fourth term, our fifth term. Well, how many terms is it going to take for us to get to something that is just slightly less than 1 over 1,000? We'll need the term that is 1 over 1,001, right? And if we're only going up by 2 each time, looks like that's going to take, from here to here, it's going to take us about 500 terms to get to having this value be less than 1 over 1,000. Does that make sense or no?
Yes, thank you.
And the reason, the reason it's the next term is because it's an alternating series. Everyone good there on 18? Okay, number 44. All right, so number 44 gives us a function f of x, which is equal to the sum from 0 to infinity of a sub n x to the n, and we've got f prime of x is equal to negative f of x for all x. We also have f of 0 is 1, and we want to know what is f of 0.2. How many decimals? To 3 decimal places. Okay, so first off, let's just write out what this series of a sub n x to the n is. So this series should look like what? Should be whatever a sub, let's try that again, whatever a sub 0 is, right? Plus a sub 1 to the, or not to the, but times x, and plus a sub 2 x squared, plus a sub 3 x cubed, and so on. And then if we were to find f prime, then first off, a sub 0, right? If f of 0 is 1, then that means that a sub 0 must be 1. And so the first derivative there, that's just a constant, that's going to disappear. And we should just end up with a sub 1 plus 2 times a sub 2 times x plus 3 times a sub 3 times x squared, and so on. So that should be what f prime of x is equal to. And if we're going to say that let's see, so we've got f prime is equal to negative f of x let me think here for 1 second. Let's see here. So we should be able to come up with our value for a sub 1, because if f of 0 equals 1, then that should tell us that negative f of 0 equals f prime of 0 from what it told us up there. And this should be f prime of 0. So negative f of 0, which is 1. So negative 1 should be f prime of 0. So we should then be able to put in a negative 1 here. So we have negative 1 plus 2a sub 2x plus 3a sub 3x squared, and so on. And we also know, like we said up here, that f prime of x is equal to negative f of x. So we should then be able to say, let's see here. That's a fun one. We could say that f of x is then equal to negative f prime of x, just by flipping the negative sign around out there. And if we know that a sub 1 was negative 1, that means that f of x is 1 minus x plus a sub 2x squared plus a sub 3x squared, and so on. That should be equal to, this being f of x, should be equal to the opposite of f prime of x, which is the opposite of negative 1 plus 2 a sub 2x plus 3 a sub 3x squared, and so on. Same thing here, and so on. And from there, we should be able to figure out what our values of a sub 2 and a sub 3 and a sub 4 and a sub 5 and everything going on towards infinity are, because we've now got, we've got 2 a sub 2x squareds here, and we've got a sub 2x squareds here. And just based on all of this, f prime of x equals negative f of x stuff, that tells us that negative 2 a sub 2 let's see. That was a fun one. So since this is our derivative, guess I should have looked through these last night, maybe. I was doing well up till this one. Oh, right. I know what I'm doing here. So this left side becomes 1 minus 2 a sub 2x. I'm just matching these things up incorrectly. 1 minus 2 a sub 2x plus 3 a sub 3x squared, and so on. And so now we can match them with the 1 and the 1 match up with each other. We have negative 1x's and negative 2 a sub 2x's. So we got negative, oh no, I lost my pen. Oh no. Okay, I got my pen back, don't worry. So we have negative 2a sub 2x's and we have negative 1x's. So negative 1 equals negative 2a sub 2. And same thing here. We have 1a sub 2x squareds. We have a sub 2x squareds, and over here we have 3a sub 3x squareds. So this should first off tell us that a sub 2 equals 1/2. And if we go to the next one, like we just said, a sub 2x squareds, so we have 1/2 x squareds, and then we have negative 3 a sub 3x squareds. So that would be negative 3 a sub 3. We should be able to simplify that down, and that should give us a negative 1/6. And if we were to continue in that pattern, here we'd have a sub 4 x to the 4, or sorry, we have a sub 3 x to the thirds, and here we would have a minus 4 a sub 4 x to the thirds. And so we could just keep going through each of these, and we'd note that this one would get multiplied by 4 to give us a sub 4. So we have negative 4 a sub 4s would be equal to our value of a sub 3, which was negative 1/6. And so that's just going to give us a sub 4 is equal to 1/24. And we should, from that point, see that there's pattern going on here, which that these are alternating, first of all, and that these are increasing. This is 2 factorial, this is 3 factorial, this is 4 factorial. So we then should be able to write out f of x now that we know what each of these a sub 2's should be, and a sub 3's and a sub 4's. So f of x was a sub 0, which we found to be, or we were given, which was 1. And then a sub 1, which we found to be negative 1, so we get 1 minus x. And then we should get plus x squared over the 2 factorial, and minus x cubed over the 3 factorial, and plus x to the 4th over the 4 factorial, and so on. And from there, it asked us to evaluate f of 0.2 and figure out what the error was, I believe. Is that right? After how many terms?
I think it says evaluate at f of 2, f of 0.2.
F of 0.2 to 3 decimal places, right? F of 0.2 to 3 decimal places. So that ought to be 1 minus 0.2 plus 0.2 squared over 2 factorial minus 0.2 cubed over 3 factorial. And we'll keep going with as many terms. We'll see how many terms we need. And this was a calculator question, so you can use your calculator to evaluate this out if you want to. But this is 0.8. 0.2 squared is 0.04 divided by 2 is 0.02. And then this one should be 0.008 over 6. And then the next one would be 0.2 to the 4th over 4 factorial, so over 24. And so that'd be 0.0016 over 24. If I take 0.0016 and divide it by 24, I don't need that term anymore to be to 3 decimal points of accuracy. And so we would just evaluate these 3. Let's 0.008 divided by 6 plus 0.02 plus 0.8 from that to be. Must be the 0.8191. Clearly, it's not going to be any of the, well, it could be the 0.8201, I guess, but going below that, so 0.819. Yeah. That was a fun one. Ah, yeah. That's good times. Okay, let me see. I know people were saying things in the chat, so let me go back and look. Are these past multiple choice questions? No, these ones are not specifically past multiple choice questions. These ones are just multiple choice questions from like one of the review books. This, I would say, is more difficult than any problem I have seen on the multiple choice of the AP test in the past. And then let me see here. I took the function, wrote out the terms, took the derivative, multiplied by -1. Yes, that is exactly what I did. So I'll go back. I'll sort of quickly go back through it. So we started off just writing out the series f. And then because we were given information about f prime and how it related to f, we also wrote out the series for f prime, knowing that a sub 0 is just a constant of 1, because that was given to us. So then we wrote out the series for f prime. And then we used this fact that negative f of x is equal to f prime of x. So that negative f of 0 should be equal to f prime of 0, which should then give us, should tell us what a sub 1 is. And once we had a value for a sub 0 and a value for a sub 1, I wrote out each of those series. So 1, and then minus x, because that's a sub 1, and then plus a sub 2x squared plus a sub 3x cubed. And I just set it equal to the opposite of our derivative. And so as the opposite of our derivative, and then kind of like we matched up x's and the coefficients on x's and x squareds and x cubes like we do when we're doing partial fraction decomposition. Did the same kind of thing there. So we matched up the number of x's here was negative 1x, and the number of x's here was negative 2a sub 2. So that's, we did negative 1 equals negative 2a sub 2, which gave us the value for a sub 2. Once we had the value for a sub 2 of a half, we took it and we plug it back in here. So we knew we had a half of an x squared, and a half of an x squared was negative 3a sub 3x squareds. And so we took a half equal to negative 3a sub 3 and solved that and got a sub 3 is negative 1/6. And so then we went back in and we said, well, we know we have negative, what did I say? Negative, I forgot the number. Negative 1/6, that's what it was. Negative 1/6 x cubes here. And the next term here would be a 4, it would be a negative 4 when I distribute the negative. So I'd have negative 4 a sub 4 x to the thirds, and that was the negative 1/6. So I set those equal to each other to find a sub 4, and then we notice the pattern. And so then once we know the pattern for how a sub 2, a sub 3, a sub 4, a sub 5 work, we should be able to plug it back into our original function of f of x, which was, we started off with 1 minus x from a sub 0 and a sub 1, and then put in our a sub 2 x squareds and our a sub 3 x cubes and our a sub 4 x fourths and so on. And once we had that, it wanted us to evaluate it, so we just plugged it in and evaluated it until we were at the right number of decimal accuracy. Good or no? Oh, good. I think that's more difficult than you should expect to see on the AP test, though, in terms of a multiple choice question. Even probably more difficult than you would expect to see a free response question. That would be like the very highest end of a difficulty level question I would expect to see. And if it's a multiple choice question, don't spend 10 minutes doing it until you're done with everything else. And then come back to it. All right, any other questions from the multiple choice? Sorry, that one took me a bit to get through. It's a good one, though. It's a fun problem. Any other questions from the multiple choice?
Can you go over 30?
30, sure. Okay, number 30. What does number 30 say? All right, 30 tells us that we're looking for the coefficient of x minus 4 to the third. What's the coefficient on this? If we're using the Taylor series about, I don't know why I wrote 4, pi over 4. Sorry, hold on one second. Sorry, so we're looking for the coefficient on the x minus pi over 4 to the third term of the Taylor series about pi over 4, which we know because of the x minus pi over 4, where f of x equals cosine x. I mean, if we just think about this, what's the term to the third should be from our third derivative of cosine. So the first derivative of cosine is negative sine, second derivative should be negative cosine, and the third derivative should be positive sine. So we're looking at a positive sine of pi over 4, which is root 2 over 2. And then since this is to the third power, we're going to multiply that by 3 factorial. So that gives us root 2 over 12, which is not one of the answer choices. Cool. That's the right answer, though. Oh, well, yeah, so root 2 over 12 is root 2 over 6 times root 2 times root 2. Over 6 root 2. So looks like it's choice D. Does that make sense? Darius, it was you that asked that one, right? Yeah, okay, cool. And let me see, on 29, you understand the answer, but why there are brackets around some of the answers. I don't know what is the Taylor polynomial order of 3x equals 1 for e to the x is. Just because they just factored the e, because there's an e in all of those terms, so they just factored the e out of them for b, c, d, and e. Because if you're doing it at x equals 1, e to the first is e, right? And then each successive term is going to have an e in it also. Does that make sense, Delphine? Yeah, okay. Okay, any other questions on the multiple choice there? How do we feel about all those in general? They're mostly okay. A couple were pretty difficult, but most of them were probably not too bad. Nobody has any other questions there?